And the answer is it's 1 minute before 12. So we go one more decade to the turn of the century. That's like right now. That's when 7% would finish using up the oil reserves of the earth. Now let's look at this in a very nice graphical way. Suppose the area of this tiny rectangle represents all the oil we used on this earth before 1940. Then in the decade of the 40s, we used this much. That's equal to the total of all that have been used in all of history. In the decade of the 50s, we used this much. That's equal to the total of all that have been used in all of history. In the decade of the 60s, we used this much. And again, that's equal to the total of all the preceding usage. Now, here we see graphically what President Carter told us. Now, if that 7% had continued through the 70s, 80s, and 90s, there's what we need. But that's all the oil there is. Now, there's a widely held belief that if you throw enough money at holes in the ground, oil is sure to come up. Well, there will be discoveries in new oil. There may be major discoveries, but look, we have to discover this much new oil if we would have that 7% growth continue 10 more years. Well, ask yourself, what do you think is the chance that oil discovered after the close of our class today will be in an amount equal to the total of all that we've known about in all of history? And then realize if all that new oil could be found, that would be sufficient to let the historic 7% growth continue 10 more years. Well, it's interesting to read what the experts say. Here's an interview in Time magazine with one of the most widely quoted oil experts in all of Texas. They ask him, but haven't many of our bigger fields been drilled nearly dry? He responds saying there's still as much oil to be found in the U.S. as has ever been produced. Now let's assume he's right. What time is it? And the answer is it's 1 minute before 12. I've read several things this guy's written. I don't think he has any understanding of this very simple arithmetic. Well, in the crisis back in the 70s, ads such as this appeared. This is from the American Electric Power Company. It was a bit reassuring, sort of saying, now don't worry too much, because we're sitting on half of the world's known supply of coal, enough for over 500 years. Now, where did that 500-year figure come from? Well, it may have had its origin in this report to the Committee on Interior and Insular Affairs of the United States Senate, because in that report we find this sentence. At current levels of output and recovery, these American coal reserves can be expected to last more than 500 years. There is one of the most dangerous statements in the literature. It's dangerous because it's true. But it isn't the truth that makes it dangerous. The danger lies in the fact that people take the sentence apart. They just say coal will last 500 years. They forget the caveat with which the sentence started. And what were those opening words? At current levels. Now, what does that mean? It means if and only if we maintain zero growth of coal production in this country. So let's look at a few numbers. We go to the annual energy review published by the U.S. Department of Energy. They give this figure as the coal demonstrated reserve base, and it carries a footnote that says about half the demonstrated reserve base is estimated to be recoverable. You cannot recover and use 100% of the coal that's in the ground. So this number is half of this number, and we'll come back to those in just a moment. Now, the report also tells us that in the year 1971, we were mining coal in this country at this rate. 20 years later, 1991, we were mining at this rate. Put those numbers together, and the average growth rate of coal production in those 20 years was 2.86% per year. And so we have to ask, well, how long could a resource last if you had steady growth in the rate of consumption till the last bit of it was used? Well, I'll just show you that equation. For the expiration time, I'll tell you, it takes first-year college calculus to derive that equation, so it can't be very difficult. You know, I have the feeling there must be dozens of people in this country who have had first-year college calculus. But let me suggest, I think that equation's probably the best-kept scientific secret of the century. Now, let me show you why. If you use that equation to calculate the life expectancy of the reserve base, or of the 1/2 the reserve base that's estimated to be recoverable, for different steady rates of growth, you find if the growth rate is 0, The small estimate would go about 240 years. The large one would go close to 500 years. So that report to the Congress was correct. But look what we get when we plug in steady growth. Back in the 1970s, we had national goal of achieving 8% per year growth rate in coal production in the United States. If that could be achieved and continued, coal would last between 37 and 46 years. President Carter cut that goal roughly in half, hoping to reach 4% per year. If that could continue, coal would last between 59 and 75 years. Here's that 2.86 that we just saw, the average for a recent 20-year period. If that could continue, coal would run out between 72 and 94 years. That's within the life expectancy of children born today. The only way we're going to get anywhere near this widely quoted 500-year figure is to do simultaneously two highly improbable things. Number one, we've got to figure out how to use 100% of the coal that's in the ground. Number two, we've got to figure out how to have 500 years of zero growth of coal production. Now, these are simple facts. Just look at those numbers. I got a report recently from the coal fields of Kentucky, West Virginia, Virginia, these giant bituminous coal fields that supply a large fraction of the electricity in the eastern United States. They estimate that maybe they have another 30 years of coal mining before it will become uneconomical to mine there. And then what will we do when we want to switch on the lights? Let's now go back and note that in the 1970s there was great national concern about energy, but this concern disappeared in the 80s. Now, the concerns about energy in the 70s prompted experts, journalists, and scientists to assure the American people that there was no reason to be concerned. So let's go back now and look at some of those assurances from the 70s so we can see what to expect as the energy crisis returns. Here is the director of the Energy Division of the Oak Ridge National Laboratories. He's telling us how expensive it is to import oil, telling us we must have big increases in our use of coal. Under these conditions, he estimates America's coal reserves are so huge they could last a minimum of 300 years, probably a maximum of 1,000 years. Now, you've just seen the facts. Now you see what an expert tells us, and what can you conclude? There was a 3-hour television special on CBS on energy. The reporter said by the lowest estimate, we have enough coal for 200 years, but the highest enough for more than 1,000 years. You've just seen the facts. Now you see what a journalist tells us after careful study. And what can you conclude? In the Journal of Chemical Education, on the page for high school chemistry teachers, an article written by the scientific staff of the journal, we read that our proved coal reserves are enormous, and they give a figure. These could satisfy present U.S. energy needs for nearly 1,000 years. Let's do long division. You take the coal they say is there, divide by what was then the current rate of consumption, and you get 180 years. Now, they didn't say current rate of consumption. They said present U.S. energy needs. Coal today supplies about 1/5, around 20% of the energy that we use in this country. So if you'd like to calculate how long this quantity of coal could satisfy present U.S. energy needs, you have to multiply this denominator by 5. When you do that, you get 36 years. They said nearly 1,000 years. Newsweek magazine, in a cover story on energy, said at present rates of consumption, we have enough coal for 666.5 years. And the 0.5 means they think it'll run out in July instead of January. Now, if you round that off and say roughly 600 years,